Algebra 1. We're back to lesson 1-1 again, part 3. This will be the last part on the simplifying radicals. Again, notice how I did the perfect squares down the line. Okay, just get into habit of doing that. It just makes it easier when you're trying to hunt and peck to try to figure out what to plug in. All right, so I'm going to start with this one here first. Now, one thing about these, when you have the square root of a fraction, it's the same thing as the square root of each number. Okay, so what's the square root of 121? 11. 120 we're going to need to break down. So what perfect square divides into 120? 4. Goes in 30 times. Well, what's the square root of 4? It's 2. So that'd be 2 root 30 over 11. You are done. Okay? So again, think of the square root over each one and then simplify each one separately. And notice, the first thing I noticed is that I couldn't reduce that fraction. I couldn't divide anything. Therefore, I just put the radicals over the top. So this one here, I'm going to do the same thing. I'm going to keep that 3 out front. I'm going to write this as root 3 over root 4. Well, what's the square root of 4? 2. I'm going to leave that 3 there with that root 3. So it'd be 3 root 3 over 2. Done. Nothing more I can simplify. And again, I couldn't reduce that first. So now I look at this one here. I can reduce this. Okay, I can reduce this. 3 goes into 27 9 times. Remember, when bases are the same and you're dividing, subtract those exponents. So what's 3 minus 1? S squared. Well, when I simplify this down, or when I break it down, I'm going to have the square root of s squared over the square root of 9. Remember that little imaginary 2 that sits here? How many times does 2 go into 2? Once. So the square root of s squared is just s. What's the square root of 9? 3. So my solution for this one here would just be s over 3. This one here, same thing. I'm going to try to reduce it first. So I sit there and I think, what goes into each one of those, or how could I reduce this? Well, this is going to reduce down to, and again, if you've got your calculators, an easier way to do it, I don't know if, like your guys' calculators, like this one here, I type in 54 over 24, hit enter, then I go to math, frac, enter, and there it put it into fraction. So my fraction here is 9/4. So I'm going to write this as the square root of 9/4. And now the same thing. It's the square root of 9 over the square root of 4, which is 3/2. Last one. We can never have a radical in the denominator, so we are doing something called rationalizing the denominator. And it's very simple. You multiply by the radical of the denominator to both the numerator and the denominator. Okay, so I'll get a totally different color here. So I'm going to multiply by both my numerator and the denominator by root 5 over root 5. So up top, I'm going to be left with 5 root 5 over, that's essentially the square root of 25, which is 5. But one thing I can conjecture is when two radicals are the exact same and I'm multiplying them, it's just going to be that number without the radical. So I can reduce this one step further. Shouldn't have put a box around it yet. I'm not done yet. So the 5's cancel. So what am I left with? Root 5. There's my answer. Done. That's rationalizing the denominator, which is a pretty easy concept. Okay, so there's the last of that simplifying radicals. I'll do one more rationalizing the denominator so you guys have it. So let's say I had, let's say root 6 over 2 root 3. Okay, or root 5 over 2 root 3. So I want to rationalize that denominator. I don't need a radical down there. So I'm going to multiply both the numerator and the denominator by that root 3. Well, what's root 5 times root 3? Root 15. Root 3 times root 3. Now remember what I said. When you have two radicals that are exact same, you're just left with just that number then. Or you can think of it as this is the square root of 9, which is 3. So then I'm going to be taking 2 times 3. So it's going to be root 15 over 6. Done. Okay? And that's rationalizing those denominators. Not a very hard concept. Pretty simple. Again, when you're doing them, check and make sure that you could, or if you can, reduce them first. And then find the roots like I did those two. But don't overcomplicate it. It's not too bad. Okay, so there it is. Lesson 11-1, Simplifying Radicals, Part 3. This is the dividing part and the rationalizing the denominator.